Hi, I'm Jack Buffington for Hackaday.com. Today we're going to solder the circuit board that we created previously in Eagle CAD. I have ordered up these circuit boards from barebonespcb.com, and we have gotten a circuit board that is just the top copper and the bottom copper, but no solder mask or silk screen. I've found that for hobby projects this is totally acceptable. And actually, even in production, I have quite a lot of things that I produce on a regular basis that I just use circuit boards like these because they're cheaper. The only place that I've ever found to have trouble with this is where I have actually left these sitting outside near the ocean for an extended period, and after about 6 months to a year, then they will fail. But unless you're sending something off to a cruise ship, which I've done, and that one didn't work too well. This is a perfectly acceptable type of board. In fact, it makes it much easier when you're prototyping, because if you need to run a little jumper wire, you don't have to scrape off solder mask and stuff like that. So let's go to our overhead camera and we'll have a little tour around of the circuit board. So right here, these big holes are strain relief holes for our battery leads, which connect up here. Here is our voltage regulator, which you won't see me solder today because I ordered the wrong one. Here is our decoupling capacitor. So it's a 0.1 microfarad capacitor. These two are for a little loop of wire that we can attach our oscilloscope lead to when we want to probe around and see what kind of signal is coming off of one of the leads of our processor or somewhere else on the circuit. Across here is our button, and this is the resistor for that button. I am totally forgetting what this is for. I will have to go look on my computer at the schematic to see what that is, but that's not terribly important for this video, as I'm mostly just showing you how to solder. This is our LED, and the resistor for the LED, should that LED not be a 3-volt one, but I have ordered 3-volt LEDs, so we're just going to put a bridge across here. And here, of course, is our processor. It's a TQFP44 part. Our programming header for the PIC kit, and the resistor for the memory clear pin. So as you can see, I've put a little bit of solder right here on the one of the TQFP44 pins. And the reason for that is when you're hand assembling things, it helps to tack down just one pin at first. So unfortunately, I've forgotten my tweezers today. I normally use tweezers, and I tend to like, I think they're, I'm not even going to guess on the brand, but pretty much they have very fine tips. It's almost like two of these pencils coming together. It's not a flat-headed tweezer like you might find a woman tweezing her eyebrows with or something like that. So I will use my big stubby fingers today to solder this part. And the most important thing here is that you want to make sure you have the right orientation on your part. So there, I've tacked down this part, and it looks like I have everything right. Another tool that I did not bring today is my loop. I have a jeweler's loop, or the one that I bought at a photography store. And you can go in and look at the parts, because sometimes when you do the technique that I'm going to do, you have solder bridges between pins. And if your eyes are getting a little bit old, it can be tricky to see that. I'm going to just move this just a tiny bit. Alright. And this is the critical part right here at the beginning. If you get all the pads aligned, things will be much easier. I'm going to tuck my head over the camera here just to get a look at the far side pins. And I think everything's looking good. So now I am going to tack down one more pin, and then I can go to my main strategy. But actually, I'm going to back up for a second. I'm using a fairly thin solder right now to tack these down. And a thinner solder just allows you to apply less solder all at once. If you use a big fat solder diameter, you end up getting big blobs of solder. So it can be helpful to use a very thin one like this. And if I am working on a part on a circuit board that has lots of little leads that I can't use this technique that I'm going to use today, I have an even thinner solder at home. I also brought with me a lead-free solder, and this, the industry is changing over to using lead-free, and I can get behind that. But if you are using a cheap soldering iron, one thing that you will find is that lead-free solder is a major pain in the butt. Unless you have a temperature-controlled soldering station, you pretty much want to avoid this because it's just massive frustration. And that's because it has a higher melting temperature, and the cheaper soldering irons tend to be set for leaded solder, lead and tin mix. Okay, back to our circuit board. What I'm going to do now would seem to be completely wrong, but it works. I am going to take solder and apply it just like this across all of the pins, so that we have just a big old mess of solder there. They're all bridged. And I'm going to do that for all four sides. And as you can see, I tacked down those two pins, and so now nothing is moving while I'm soldering. And you don't want the part to move around while you're soldering, because obviously that's going to cause problems. Sometimes you can kind of pull away the solder like that. I got most of those pins doing that. But that's not the technique that I'm trying to show you today. Finally, we'll do this side. Okay. So now we have a huge mess. Let's fix that. Here is stuff. It typically comes in a roll like this, and it's called solder wick. And pretty much what it is it's finely woven solder, or finely woven copper that has a little bit of flux on it. And what I'm going to do is I'm going to take this and just lay this down and turned up the temperature on my soldering iron a little bit to help out here. There we go, I think it took. And as you can see, it sucked off most of the solder there, and I'm just going to continue around and keep doing that. And so, sort of like magic, you get, let's see if I can pull that out of there. This is where the jeweler's loop would help. You guys at home may be able to see this better than I can because we've got the camera zoomed in. But I think, looking at that I have all the solder off of there. Just suck that all up. There we go. I think that side is good. You want to make sure to use or to solder all of your TQFP or all of your surface mount parts first, before going to through hole, and that is because, you know, laying your soldering iron down like this, or just getting in there and manipulating with tweezers and the tip of your soldering iron can be tricky if you've got other parts sticking way up from the edge of the circuit board. We've just got a couple more here. So I'm not sure if I said this before. This may need to just be cut out, but I'm backing away so that we can easily just skip over this if we need to. When I designed the part in Eagle CAD, what I did was add a little extra on to the pads. And what this did was allow me to easily run a wire over to somewhere else. Let's say this pad that is not connected needed to be connected over to here. I can now easily solder a little, or not easily, but I can solder a circuit board or a thin wire from here to somewhere else. Whereas by default, manufacturers tend to specify their land pattern in such a way that there is just enough for the feet of the leads to touch and nothing more. And that's not terribly hobby friendly or rework friendly. So I sometimes extend this so that you can more easily work with the chip. Alright, now we are ready to start adding parts onto the circuit board. And we'll just start here with the 2.1 microfarad capacitors. Now I am using a Panavice circuit board holder. This is a super handy thing. It's not necessary, but it keeps the board nice and steady. If you have leads sitting on the bottom and you're trying to work on it on a table, it can be rocking around as you're soldering it. So this is a pretty handy thing, not totally necessary for hobby use. We have a spring-loaded little doodad there, which I'm going to have to use because I have this a little low and I can't flip it over. So I like to take my leads and bend them out like this so that now they stay put, and now I can go ahead and solder them. I think it's a good idea to just do a few parts at a time, otherwise you get a real mess of leads going on. When you're soldering, you want to touch your soldering iron to the lead in the pad and then bring in the solder like I'm doing here. And as you can see, these are relatively good solder points. You don't want a big ball. You don't want a ball, and you don't want it to be totally flat across there as well. And I'll do one incorrectly on one of the next parts, so you can see what those look like. So next, I'm going to put in my LED. When working with LEDs, you want to make sure that you have the orientation right. This particular LED does not have a flat side on it, but I'm pretty sure that I've got it correct. So I've taken that, bent the leads over, And now I'm going to solder these incorrectly. This first one I'm going to attempt, it's tricky because I've been doing this for so many years that I tend to get it right, but I'm going to attempt to have sort of a dry solder connection. I think I did pretty good at that. So what we have here, this connection it'll work, as will the other one, but you know you risk underdoing it like that. So this one's totally flat. I don't know that I can really show you a profile, and then I'll try to do wrong on this one. So that one I've added way too much solder on there, and let's see if I can give you a little bit of perspective on that. I don't know if you can see that in profile, but the one right here is pretty much a dry solder connection, and so it's just totally flat. And this one here is too much. It's more of a ball. How it should really look is sort of like maybe a volcano or a teepee. That will be your best solder joint. So let's just touch this up a little bit. I can go ahead and grab a little bit of that solder off of there. Like this. You could also have a desoldering bulb or a solder sucker that's spring-loaded. My experience has shown that the little solder suckers are not worth your time. You need to get a big one. Alright, we're just going to zoom through this a little bit. We've got the header right here, the programming header that I just put into there. Now this one, you can't bend those leads. So what you need to do is you have to hold it while you're soldering, which is a little tricky. So I'll gather up a little bit of solder on the tip of my soldering iron and just touch it to one of the leads. And you need to make sure that that is not one of the leads that you are touching with your finger, otherwise you will burn your finger, which isn't the end of the world. And I'll just get this a little bit straighter, and we'll finish up with that one. And I think at this point we're just going to fast forward through everything while I do this. You can just kind of watch in fast motion, because soldering circuit boards is kind of like, it's not the most riveting viewing. Here I'm placing in a bent over piece of one of the leads that I snipped off recently, and this is my ground point for my oscilloscope. So you can see that in profile there. Okay, the final thing that I'm going to do today is to solder the battery leads onto this circuit board. Now, I have strain relief holes here, and the reason for that is if I just soldered these on like this, they would wiggle at exactly this point right where they go in, and they would break in fairly short order, especially if this is a project that you're still debugging and working on, and that's a real pain. So what we want to do is we want to have our leads come in like this, go down through the circuit board and come back up. Find that hole. Having a little difficulty here. There we go. And then back down one more time, like that. Now I'm going to snug this up a little bit, just for now, and then we'll tighten them up a lot later. These wires are going to be a lot less likely to fail because they'll be flexing at a point where their insulation is. And so the insulation will prevent the wire from bending nearly as much. So it's like that. And so now the wire will be bending still, but it'll be bending over a much greater radius. So that's pretty much it. Today we soldered together a circuit board that included a rather daunting part for beginners, which is a surface mount part with lots of leads. We have some through-hole components. We had a component that you can't bend the leads for, and we have some wires. So for Hackaday.com, this is Jack Buffington signing out.